Hello guys, welcome to our class for today. This is Noble Mind Science Tutors Online, and this is your online video tutorials. I remain Uncle Michael, and I am your online video tutor. So for today we are going to be looking at sound waves. We'll be looking at sound waves, propagation of sound waves, factors that affect sound waves, velocity of sound, and then we'll also look at echoes and solve some problems. So that's okay. So we'll also look at reflection of sound, which is echo, application of echo, and then we'll also solve some problems. Alright, so that is what we're going to be taking for our today's class. So I hope you are ready for the class. If you are ready, then I will encourage you to get your writing materials. And before then, please, if you have not subscribed, please click on the subscribe button, click on the notification bell so that whenever we upload a new video, YouTube will notify you. Alright, so if we are ready, then let's go straight to the class for today. Sound waves. Sound waves. So we know that sound is a form of energy, okay, and it is normally produced by the vibration of a body. Like when you have a vibration of a turning fork, you have a sound wave, the vibration of air column in pipes, or the vibration of a plug string in the form like in a guitar, or even when you vibrate air, vibration of air in a trumpet. All these all these situations produces sound waves. So sound wave is actually produced by vibration of a body. Okay, vibration of a body, that is what produces sound wave. So for a sound to be heard, there must be the presence of a material medium, and that is what we're going to demonstrate now. And if you want to demonstrate that sound requires a material medium, this is just the setup that you need. Okay, so what you need for this particular setup is an electric bell that is covered by a bell jar. Okay, so this is an electric bell. See, this is the electric bell. So you cover it with this bell jar. Then the bell jar has two openings. One of the openings is connected to a vacuum pump so that you can use it to remove air from this bell jar. Then the other part is connected to electrical terminals. So if you are able to have this setup, then you can actually demonstrate that sound wave requires a material medium for its transmission or for its propagation. So how do you do this? What you will do is that when you close this electric circuit, if you close its terminals, you will see that the bell will be ringing and it will be audible. You know, the bell will be audible just like your normal house bell. It will ring very well. Now switch off the vacuum pump and begin and begin to remove air. Pump air out of the bell jar. You will find out that as air is being removed from this bell jar, the sound of the bell will start to faint. It will start to reducing gradually, and the more air is being removed, the more the sound will get fainter. Okay, the sound will get fainter, even though you will still be seeing that the bell is ringing. So you will see that the bell is still ringing, but the sound will be fainter. Now, if you reintroduce air into the badger, you find out that the laudability of the sound will now come up again. That the sound will become loud again. So from this simple experiment, it shows that sound requires a material medium for its transmission. So you can now see that sound cannot travel through a vacuum. It requires air to travel. It requires a solid medium to travel. Okay, so sound does not travel through a vacuum. Sound requires a material medium to travel, or to be transmitted, and this is what this experiment is. So if you are asked such a question, just describe the working of this bay, the pump and then that is just it, as simple as that. Okay, so this shows that sound wave requires a material medium. And we also want to know that sound, as we have mentioned before, in wave motion, sound is a form of a longitudinal wave. And that's what we're going to discuss next. Sound is a form of longitudinal wave. What that means simply is that it travels parallel to the source of the vibration. It travels parallel to the source of vibration. And as I've said before, sound can be transmitted through solids, through liquids, and through gases. So from our previous experiment, we discovered that sound can travel through gases, which is air. Sound can also travel through liquid, that is water. Sound can travel to solids, just such as a string. Sound can travel through a string. And for different medium, sound has different velocity. Like in air, the approximate velocity of sound is 332 meters per second. In liquid, it's about 1,435 meters per second, and in solid, it's about 5,000 meters per second. So we know that general wave equation states that the velocity of a wave is equal to lambda f, and velocity is lambda f for a wave. Alright, so this is the general equation for wave, and lambda is equals to v over f. Okay, I think that is what I actually wanted to write here, but due to reason, this is devil's pen. So lambda from this particular equation, lambda is equal to velocity all over frequency, and these are the meaning of the different symbols. Okay, these are the meaning of the different symbols. That v, velocity of sound, lambda, this is wavelength, f is frequency, then t is the period of the wave. We know that t is something as t is equals to 1 all over f. So t is equals to 1 all over f. Okay, t is equals to 1 all over f. So these are some of the simple equations for wave, and based on that, so t is 1 over f, and also from this equation we can also write that v is equals to lambda all over t. It's equal lambda all over t, knowing that 1 over t is equals to 1 over t is equals to f. Okay, so these are some equations that we'll discuss or use to solve some problem as we progress. So what are some of the factors that affect the velocity of sound? What are some of the factors that affect the velocity of sound? So this is what we're going to be discussing next. Factors that affect the velocity of sound. One of them is density. Another one is wind direction. Okay, so if the sound and the direction of the wind, they are the same, if the sound and the direction of the wind, they are the same, then you have increase in sound. But if the direction of the sound is opposite to the to, if the direction is opposite to that of the sun, that is the direction of the wind, if it is opposite to the direction of the sun, then the velocity will decrease. But if they are traveling, if the wind and the sun, they are traveling in the same direction, the velocity of the sound wave will increase. Okay, so that is the effect of wind direction on sound. Then the other one is temperature. Okay, so the speed of sound increases as the air temperature increases. So from mathematical equation, it has been derived that the velocity of sound is directly proportional to the square root of the absolute temperature. Velocity of sound is directly proportional to the square root of the absolute temperature. So it's either v is equals to square root t or v is equals to square root theta. As the case may be, these two equations are the same. You can either use t or you can use theta. It depends on you. So there's something that you need to know there, that the pitch and loudness of sound has no effect on the velocity of sound. No. Also, pressure of the surrounding air has no effect on the velocity of sound. So the only factors that affect the velocity of sound, they are the temperature, wind direction, and the density of the medium. So just take note of that: density, temperature, and wind direction. These are what affects the velocity of sound. We have said that pitch, loudness has no effect, and also pressure has no effect on the velocity of sound. So just take note of that. Okay, so this is basically the introduction to sound wave, and we are going to solve some problems based on what we have discussed before. We now look at reflection of sound. Okay, so let's just solve some problems quickly before we look at reflection of sound. So this is a sample question that I want us to look at. This one says, if the velocity of sound in air at 0 degrees centigrade is 332 meters per second, calculate the velocity of sound at 30 degrees centigrade. So in this place now, in this particular question, we are given initial temperature T1 to be equals to 0 degrees centigrade. You know that you have to convert this to absolute temperature by adding it to what? 273. So you convert it to that. So you have this one is equals to 273 Kelvin. Okay. Then you have T2, which is final temperature, is equals to 30 degrees centigrade. So you also convert it. Okay. So this is equals to 303 Kelvin temperature. Then you are given the velocity of sound in air to be equals to 332 meters per second. Now we are told that velocity of sound is directly proportional to the square root of the absolute temperature. So mathematically today, it means that V1 all over T all over square root T1 is equals to V2 all over square root T2. So we know V1, but V2 we don't know. V2 we don't know. So what I'm going to do, substitute into this equation. So if we substitute here, we are going to have V1, which is 332 all over the square root of 273 is equals to V2 all over square root of 303. Okay, so you work this out and make V2 the subject formula by cross multiplying. So if we make V2 the subject of formula, we are going to have that V2 is equals to 332 multiplied by square root 303 all divided by square root 273. Okay, so we can work that out. We can work this out. So if you work this out so that you can have your answer readily, use your calculator to work all this out. If you work this out, you have that V2 is equal to 349.78 meters per second, which is approximately 350 meters per second. Okay, so that is how to use this formula to solve problems on the sound waves. Okay, so this is how to use this formula. Let's solve another one. Question 2. Calculate the wavelength of the sound from a tuning fork which vibrates at a frequency of 250 Hz in air. Take velocity of sound in air as 330 meters per second. So this one is direct. You have been given frequency. Frequency has been given to you to be 250 Hz. Okay. Then you are given velocity to be 330 meters per second. So we know that from V is equals to lambda F. Lambda is equals to what? V over F. So what you do, just substitute to this. That is 330 divided by 250. Okay. So once you work this out, you will have your wavelength. Alright, so your wavelength here will be equals to 1.32 meters, as the case may be. Right, so I hope this one is relatively simple. You can easily relate with this and solve any problems on this, right? So this is another question. Question number 3. A source of sound produces waves in air of wavelength 1.65 meters. If the speed of sound in air is 330 meters per second, the period of vibration in second is what? It's a wire question. So here you are be given a lambda, which is wavelength, to be equals to 1.65 meters. You are given the speed of sound to be 330 meters, and then you ask to find the period of the wave. Now from V is equals to lambda F, we also had that V is equals to lambda all over T. So which means that T is equals to what? Lambda all over V. So once you have that, substitute into the equation, lambda is what? 1.65, and your V is 330. Okay, so by the time you solve that out, you are going to have the period of the wave, and that will give you 0.005 seconds. Okay, so this is what you will have. I hope this one is also simple too. Okay, so if you can relate with this, thank you so much. I hope that you are following, and I will also encourage you to solve more problems. All right, so we are now going straight to um, reflection of sound, echoes. Reflection of sound, echoes. Okay, so echo is just like when you are in a room. If you're in a room where you don't have much properties, right, and you talk, you'll be hearing back your voice. That effect is what is called echo, and in physics it's called reflection of sound. Okay, so it is reflection of sound that gives you echo. It's a reflection of sound that gives you echo. Okay, so an echo is a sound heard after the reflection of sound waves from a plane surface. So when a sound wave is released and it hits a a plane surface, it will reflect back. That reflection of sound is what is called echo. So sometimes when you clap, you will hear your sound back. That is an echo. If you shout, you will hear your voice back. That is an echo. Okay, so that is what echo is all about. So you know that when sound travels, it covers a particular distance. Now, for it to come back again, it will cover that same amount of distance. So which means that for an echo to be heard, the sound will travel twice the initial distance. Okay, the sound will travel twice the initial distance. So the velocity, we know that velocity is equals to total distance covered all over time taken. So in the case of echo, if the distance traveled is given to be x centimeters, if the distance from the initiator of the sound to the reflecting surface is x centimeter, then the total distance traveled will be equals to 2x centimeters at time t. So which means that velocity is equals to total distance traveled all over time taken, which is 2s all over t. Therefore, distance is equals to, you can make distance with a formula, distance will be equals to velocity and time all over 2. So these are the two basic equations for echo. These are the two basic equations for echo that we need to take note of. Is that okay? Alright, so echo can also be described as reverberation. But the only difference is that reverberation is the persistence of a sound after the source that is producing the sound has stopped producing that sound. Right? So when you hear a sound after the source that produces sound has stopped producing the sound, that effect is what is called reverberation. Okay, so it happens mostly in some kind of rooms where the wall does not have acoustic. You hear one sound repeating itself severally. Even when the music has stopped, you hear the sound still going on. That is called reverberation of sound. And that is what we'll discuss next. So, just as I've said, reverberation of sound is the persistence or the perseverance of sound after the source producing sound have stopped producing it. So if you want to reduce these effects, you have to make the wall to be acoustic. That is, there should be some kind of lagging on the wall. Okay, so for you to reduce the effect of vibration, you make the wall to be acoustic. So you cover the wall with some kind of sealing materials that are perforated, sort of, so that that effect will be reduced. And that is what they normally do in musical studios. That's why when you enter a musical studio, any sound that comes out of it is always very clear because they have reduced the effect of reverberation by making the wall to be acoustic. All right. Okay, so that is about reverberation. Then application of echoes. In which area are echo beneficial to humans? One, echo can be used to determine the speed of sound in air. Just as I've said now, speed of sound is equals to two times distance traveled over time taken. So in that area, we can use echo to determine the speed of sound in air. It is also used to determine the distance of sound waves from source. Okay, we've gotten the equation for calculation of distance. It is used to sound, its echo sound is used to determine the location of objects underwater. There's what is called echo sounding. If a ship or if there's an object that they are looking for under the sea, you can use echo sound with some sophisticated equipment to locate that object. Alright, so it is used to actually locate objects underwater, and echo sound is used to determine the depth of sea. It is used to determine the depth of sea. So these are some of the areas where echo are applied, and these are very key. Please, you need to take note of these few points. Okay, so right away we'll just take some problems on echo, and then that will be it for this particular lecture. So this is a sample question again that I want to look at. Question number 1 says that the velocity of sound wave at 27 degrees centigrade is 360 meters. Calculate the velocity at 127 degrees centigrade. Okay, so just like we did before, we have been given T1 to be equals to 27 degrees centigrade. So convert it to absolute temperature so that we'll have because this is a JAM question, so you don't really have to waste time. You have to be fast in your calculations. That's okay. So this will give you 300 Kelvin. Okay, then T2 I'll be giving to you to be 127. So just add this to 273. Okay, so if I add this together, you're going to add to 2 equals to 400 Kelvin. Alright, so then you are giving V1 to be equals to 360 degrees, 360 meters per second. So V2 is what we are looking for. So from this our equation that we use, say that V1 all over square root T1 is equals to V2 all over square root T2. Make V2 your subject of formula by cross multiplying. You have V2 is equals to V1 square root T2 all over what? Square root T1. So once you have done this, what you need to do next is to substitute your values. So when you substitute your values, you are going to have 360 multiplied by square root T2, which is square root 400 all over what? Square root all over square root 300. So by the time you do all your calculations and you work this out, you will have your answer. Your answer will come out readily. Okay, by the time you work this out, your answers will come out readily. So if you work that out, press your calculator, you will have that the velocity is equals to 416.1 meters per second. So punch that out in your calculator. You have 416.1 meters per second. That's okay. So because I don't want to dwell on it because we've discussed all this, I've done all this before. This is simple mathematical manipulation that any student can do. So just do that, get your calculator, and then you have your answer, right? Okay. So this is another sample question, still on echo. A man standing 510 meters away from a wall sounds a whistle. The echo from the wall reaches him 3 seconds later. Calculate the velocity of the sound in air. Alright, so here you are giving distance is equals to 510 meters. You are giving the time for the echo to reach the man as 3 seconds. We are asked to calculate velocity. Velocity is unknown, is it not? So we had that V from echo is a 2D all over T. Alright, so just substitute into this equation, we have 2 times 510 divided by the time, which is 3. So by the time you work this out, you will have that the velocity of this sound is equal to 340 meters per second. So this is an echo objective question. Okay, so let's try our hands on another one. This one says that how far from a cliff should a boy standing should a boy standing in order or should a boy stand in order to hear the echo of his clap 0.9 seconds later. Speed of sound in air is 330 meters per second. Okay, so they said how far from a cliff should a boy stand in order to hear the echo of his clap 0.9 seconds later. Stand in order to hear. Okay, so here you are giving time to be equals to 0.9 seconds. Velocity of sound in air is 330 meters per second. Distance is what we are looking for, is unknown. Okay, so having done that, we've seen that velocity is equals to 2d all over time, and from that equation we are able to get that d distance equals to what? Vt all over 2. So if we substitute into this equation, we have 330 multiplied by 0.9 all over 2. So if you work that out, you have the distance. So that will give us 148.5 meters. So this will be the distance. This will be the distance. Alright, so let's try our hand again on another one. Okay, so we have solved most of the problems. I've covered a lot on this topic, and I hope that we have been able to solve any problem. We've been able to solve some problems to drive home the point. So what you need to do is now to check your understanding. That is why you don't play with this particular page. Make sure you solve all these problems. Check your JAMB question, check your WAEC questions. We see questions on echo, on transmission of sound, propagation of sound, on that. Solve all the problems. If you have any challenge, put them in our WhatsApp chat, right? We guide you on how to solve the problems in case you have any challenge. So thank you so much, guys. But before I go, please, if you have not subscribed to our channel, please subscribe to this channel. Click on the notification bell so that when we upload a new video, YouTube will notify you. This is Noble Mind Science Tutors Online. You can reach us through the WhatsApp number that is showing on your screen. Okay, so I hope you have enjoyed our lecture. Give us a thumbs up, give us a like so that you can continue to encourage us, now. So please have a nice day, have a wonderful time, invite your friends so that they can also come and enjoy what you are enjoying on YouTube. Okay, so thanks a lot, and we hope to see you in our next class. Thanks.